I'm going to explain this and solve the questions from the practice sheet on iLearn that he posted about your quiz. Wallah, if I saw one grade less than 10 in the quiz. Okay? I'm gonna find you. طيب? It's 5 questions. يعني
It's 2 questions.
2 questions, 5 on the practice, I mean. 1 integral test, and he's telling you the test. Don't do divergence test or DCT or whatever. And 1 question estimation, the error estimation, whatever this is called. Okay? طيب. So what is integral test and when do we use it? Now, I'm gonna first answer when do we use it. If a function f of x is continuous, positive, and decreasing. And by f of x, I mean here you can say for any series n goes from 1 to infinity. There is nothing special about 1. It could be 2, 3, 4, 5, I don't care. It depends on the question, it doesn't matter. If f of x, which is equal to the sequence, okay, which is equal to the sequence inside that series, is continuous, positive, and decreasing on the interval 1 to infinity. Again, there is nothing special about this one. Okay? This guy follows the starting index of the series, whatever that number is. Okay? Then we can apply integral test. Then we can apply integral test. Now, how do I check continuous? Check that you don't have fractions, denominators equal 0. You don't have negative square roots, these kind of things, okay? Positive, just by staring, you can sense it's positive or not. By just looking at it, you will see, okay? And decreasing, exactly. F prime of x has to be negative, right? Or you can do the or. If you don't like the derivative, you can do ratio test. an plus 1 over an less than 1. But usually the questions will be better solved with derivatives. Okay? What does the test say? The statement says, if the integration from 1 to infinity, again, follows the sequence, the starting index of the series, f of x dx converges, then my series converges. Okay? And if the integration diverges, then my series diverges. Is that clear? Okay? So you don't test the series directly. You evaluate an improper integration. I hope you still remember 7.8. Okay? You actually need to integrate. You need to, using the techniques, whatever techniques or whatever rules we have. Okay? Don't use DCT to evaluate this integration. Okay? So be careful. Okay, that's it. We can start solving. Okay? Example. So the question will be what? Determine if the series converge or diverge. Determine if the following converge or diverge. Okay? Of course, also to apply integral test, continuous, positive, and decreasing have to be met, And obviously you should be able to integrate it, right, using the things you learned before. And between us, it's going to be either substitution or by parts, or like a simple one, like direct rule, tan inverse, these kind of things. Okay? Right. Now, so we're going to say let f of x be equal to the sequence. So x over x squared plus 4. Now, is this always positive, the function itself? Remember, x squared is positive always, plus 4 is always positive. Is x positive or can it be negative? Always positive. Why? Because it's 1 to infinity. Be careful. We're working from 1 to infinity in series, or 2 to infinity, whatever, like a positive interval. So this is always positive, always positive, always positive. So this is positive. Okay? Okay? Is it continuous? Is there any number that you plug and you get a 0 in the denominator? No. Okay, good. So positive and continuous can be just visually seen. Okay, you just have to mention. But of course you have to be sure that they are positive and continuous. So which is positive, and then continuous and decreasing on 1 to infinity. Why is it decreasing? Let's compute the derivative. Okay? So what's the derivative? Quotient rule. What does it say? Derivative of the top times the bottom minus the derivative of the bottom times the top. So 2x squared divided by x squared plus 4 whole squared. And then what do I obtain? Minus x squared plus 4 divided by x squared plus 4 whole squared. Is this always negative? Now this is always positive. And x is between 1 to infinity. So like, let's say 5, 6, 7 minus a big number plus 4 is still minus, right? And then over a positive is negative. Is that clear? Can you see it's negative, the derivative? Always. Okay? Well, if you plug 1 or 2, it is positive, right? But what we care about is what? On the long run, you know, closer to infinity, what happens, right? Okay. But if you plug 2, you're gonna get 0. If you plug 3, it's gonna be negative and so on. Yes?
How do you know it's continuous?
How do you know it's continuous? Is there any number that you plug and you get denominator 0? What does this continuous mean? Denominator 0, or negative inside the square root, right? Or negative inside a ln. These are the only 3 types of problems we have about continuity. Okay? Okay. Now I can apply integral test. I still didn't solve. So now we're going to take the integration 1 to infinity x divided by x squared plus 4. Now this is you on your integration skills. How do I do this integration? I told you, it's either a simple one, substitution, or by parts. Okay? So this is a substitution. I can see a function and the derivative, right? So u equal x squared plus 4, and then du is what? 2x dx. You can put a 2 if you want, and then divide by 2. Okay? So this becomes what? Half integration. Since we did a substitution, let's change the bounds. So if x is equal to 1, u equals how much? And if x equals to infinity, u equals infinity, right? So I'm integrating from 5 to infinity, 1 over u, and half ln u from 5 to infinity. Okay? No. This is wrong. Why? Because in improper integration, what did we do? replace infinity with t. Yes. Okay, so you can't do this. You can't do this. Okay? So you say limit as t goes to infinity of half len u from 5 to infinity. Okay? Now from 5 to t. Sorry. From 5 to t. Okay? Plug the t and the 5 and then evaluate the limit. So limit as t goes to infinity, half len t minus half in 5. What is len of infinity? Infinity. Infinity. Try it on the calculator. If you kept increasing the number, it will just increase. Infinity. Minus a constant stays infinity, right? Okay, so this diverges. Equal infinity, so diverges. So you can say, you can answer like this. Since the integration of f of x dx diverges, then the series must diverge. Any questions? Another one. Let's do another. So so again, the same thing. Let f of x be equal to what? X to the power 5, e to the minus x power 6. Okay? If you cannot see the function that is positive, continuous, and decreasing like this, then maybe try to put it down if you want. It's fine. Okay, is it always positive? Let's check. Now, remember, x is between 1 to infinity from the bounds of the series, right? So anything from 1 to infinity power 5 is positive. E, by definition, E is always positive, you know, from its graph. How does the graph of E look? Like this. It's always a positive, it's above the x-axis. Anything you plug here is positive. So positive over positive is positive. So which is positive and continuous. Now, why is it continuous? Any problems here with this fraction? Is there any number that I can plug here and makes it 0? Nothing, right? Any number, E is never 0, right? And E is never negative. E is 0 only at minus infinity, but that's not a number yet. Okay? So it's always continuous. And then what do I have? Decreasing. So to prove decreasing, let's take the derivative. Okay? Let's take the derivative, and you can apply quotient rule. So what do you obtain? 5x power 4 e to the x power 6 minus what? E to the x power 6, 6x power 5 times x power 5 divided by e to the x power 6 whole square. Now, if you simplify this, if you take the e power x power 6 out, what do you get? 5x power 4 minus this times that. So 6x power 10. And then e to the x power 4. Okay? Now what? What do I have? This is always positive, right? And what's this? This is always negative, right? Because you have a small number minus a much bigger power, right? So it's always negative. You can plug and test if you want. Okay? So this is always less than 0. So it's positive, continuous, and decreasing. On the interval 1 to 2. Okay? Now, what will I do now? Take the integration. Okay? Take the integration. Let me do it here. Anybody needs this? Right. Now, what do we have? Integration from 1 to infinity, x power 5 e to the minus x power 6 dx. How do I integrate this? You have to check. Again, it's multiplication, two function, different types, but is it substitution? This is what you have to think about first. It's substitution. I can see a function of this derivative. So u equal, you can take x power 6 alone or minus, it doesn't matter that much. Okay? It's up to you. Minus 6x power 5, okay? dx. So I need a minus 6 here. So I can put a minus 6 and minus 1 over 6. Okay? So this becomes minus 1 over 6, integration. This with this is du, and e to the u, right? And let me change the bounds. Now if x is 1, how much is u? If x equal 1, u equals minus 1. If x equal infinity, u equals minus infinity. So you say 1 becomes minus 1, infinity becomes minus infinity. And then, what do? You integrate. Minus 1 over 6. Integration of e is itself. And then from minus 1 to t. Then you say limit. As t goes to minus infinity. So, limit t goes to minus infinity. E to the t minus e to the minus 1. Now plug the element. What's e to the minus infinity? 0. That's it. So this is 0. Minus 1 over 6 times minus e power 1 is just 1 over 6 e power minus 1, which converges. Okay? So you can say, since the integration converge, then the series. Any questions? Okay. I'm gonna put 2 more questions, but I'm not gonna solve them. I just wanna show you like some common examples that usually appear in exams. Okay. I'll just tell you the integration technique. Okay. Now, this is always positive and continuous and decreasing, right? So we can say here, what? Let f of x equal what? 1 over x. Now, is this always positive? X is always from 1 to infinity positive. Len is always positive when you plug numbers like 1 or larger. And that's it. So this is always positive. Positive. Is it continuous? Is there any number you plug gives you 0 denominator? No. There is 0, but it's outside the interval, so I don't care. So that's continuous. Is it decreasing? Yes. Obviously. If this is not obvious, take the derivative. But this is obvious because this number here, once you increase it, it increases 1, and this stays 1. 1 over a growing number, it's a decreasing overall, right? So this is decreasing from 1 to infinity. So when I want to do the integration now, what do I obtain? Oh, sorry, what's the technique of integration? What's the technique? Yalla. What's the function? What's the derivative? Which function is in here? If I differentiate it, I'll get a derivative in here as well. ln. Yes, that's it. Okay, so u equals. Now, can you take ln squared? It wouldn't work. Okay, and then du is what? 1 over x dx. And then what does it become? Integration. Now, if you want to change the bound, ln 1 is 0, ln infinity is infinity. And this becomes 1 over x. 1 over x dx is du. And then 1 over 9 plus u squared. How do you solve this? What is this? 1 over 3 tan inverse u over 3 from 0 to t. And then limit as t goes to infinity, right? Don't forget that. So what do you get? 1 over 3 tan inverse t over 3 minus 1 over 3 tan inverse of 0, right? And then again, limit as t goes to infinity. What's tan inverse of infinity? Pi over 2. Tan inverse of 0 is 0. So this converge. Done. So since the integration converge, then a and converge. Proceeds. That's it. I said I'll not solve it, I solved it. Okay. Right. One more. This is not in your practice sheet, but it's good for the exam. I've seen it a lot. Okay? So integration, no integration. Yeah, tell me. Again. So, okay, I will not solve this one. But this is continuous positive decreasing. There is no problems with it. But when I want to do the integration, how will I do it?
U is 1 plus x squared.
No. I mean, wait.
1 plus x squared. U is 1 plus x squared.
Who said what? U is 1 plus x squared?
U is 1 plus x squared. No, it's 1 plus x squared. Which one?
Both of you are right, by the way. Both of you are right. How? U equal 1 plus x squared. Du is 2x dx, right? So it's 2x dx. Okay? Or u equals ln 1 plus x squared. Du is what? Derivative?
Professor, how do you know this one's decreasing?
You can take the derivative, but it will be painful.
Yeah,
Or you can prove somehow that this is larger than this. That's it.
yeah, but in the exam, how would we have something to know that it's decreasing?
Positive and continuous, they don't, just visually you can say, they don't expect any solutions. But decreasing, you have to take the derivative here.
Professor, to be so hard. And probably through that to
طيب عادي. Guys are not kids, يعني you can do it.
Can we take
Actually, I don't know. Like, I'm not gonna grade.
The question tell us that it's decreasing.
Huh?
Will the question maybe tell us that it's decreasing?
Maybe.
Can we compare the distance?
The degrees. You can say that. Yeah. Why? Because this is degree 1 and this is degree 2, and ln is a, like, you can say it's degree between 0 and 1, so it really adds to the power, okay, in a certain way. So this is degree larger than 2 for sure, okay, this is what I mean. And then this is degree 1, so you could say that. Or you could just make a statement that this is larger than this, and it's a correct statement. It's a correct statement. You can say since 1 plus n squared, ln 1 plus n squared is larger than 2n for all values of n, then it's decreasing, and then you can do it. I think it's fine. You can just double check with the professor, because for me, for example, this seems right. to say this statement, but I don't know if he really wants you just to take the derivative, you know? Right. Now, if I wanna integrate, what do I get? 2x over 1 plus x squared. Dx is just du, and then this is just 1 over u. That's it. But if you follow this, what do you get? 2x dx is du, and then I have 1 over u ln u. And then this becomes similar to this one. And then you have to do another substitution here. You know, you can say t equals ln u, and then dt is 1 over u du. And then it's gonna end up like this. Okay? But this is just a shortcut, faster. If you spot it, it's correct. And this is correct also. Okay? This is correct also. So it's just up to you, whatever you want. Right? Clear? Okay. One more from the practice. What's the time?
32.
With no solving, does this converge or diverge?
No.
No solving. Converge. Why? See? Okay. So this converge since p equal root 3, which is larger than 1. Remember, if you forgot this, this is exactly like p integration, but series version. Okay? This is diverge if p is what? Less than or equal 1. Converge if p is larger than 1. Let's say he asked you to prove this. How do you solve this question? Like, how do they do p-test? How did they know that this is less than 1 conversion? This is how? Just take integral test here, and then if you forgot this, for example, take integral test here. You can integrate this 1 over x power a constant. You can take it up and then add 1, and then, and then you'll end up with a conversion for this one. Okay? So this is how they proved this, by just simply taking integration 1 over x power p, whatever p is. Okay? So this can be proved by integral test. This is what I want to say. Can be proved by it's not just someone came and just said these rules and typed in. Okay? Type. One more. So let f of x 1 over x squared plus 25. Is this continuous? Is there any number you plug and you get 0 here? No. Is it positive? This is always positive, this is positive, so yeah, which is positive, continuous, and it's decreasing. Let's check. And decreasing since f prime of x is how much? Yalla, take the derivative. Quotient rule again. Derivative of the top times the bottom, that's 0. Minus derivative of the bottom times the top over the bottom square. This is always positive. 2x is a positive number, right? Because x is between 1 to infinity, right? And this is negative. So this is always negative. Okay? And 1 to infinity. Take the integration. How much is this? This is directly tan inverse. Straightforward. 1 over 5 tan inverse from 1 to t, and you need to do the limit as t goes to infinity. So limit t goes to infinity. Plug the t minus plug the 1. What do you get? 1 over 5, pi over 2, minus 1 over 5, tan inverse 1 over 5. I don't care what's this, these are just numbers, so this converges. Okay? Since the integration converges, series converges. That's all. Okay? Since 1 to infinity converges, then the series converges. Good. So the last topic is estimation of sums. Okay. And you have only one question about this in the sheet, and it will come the same, I'm sure. So don't mess this up, please. Okay. Sums. Now let me explain the topic briefly about calculation of the sums. Now let me consider this. Consider this series n equal 1 to infinity 1 over n squared. Okay. Now, for example, in engineering, we don't like to evaluate exact sums of series. This is too much to do, right? And they're not good with math, so they can't evaluate the exact number of this sum. Okay? So what they do is they take what we call a partial sum, which means the first few terms. So if you plug 1, you get 1. If you plug 2, you get 1 over 4. And then 1 over 9, right? And so on. And you keep summing. But what do engineers say? They will say, I'm going to take this, the first, how many times here? 6 times. Can someone use a calculator and find this exact number? So I would say this is approximately okay, and find this exact number. The first few terms. 1.4913. Good. Now, let me tell you the exact sum of this. So the exact sum of this is pi squared over 6. You don't need to know the details of how they got to this number, but I need someone to calculate this also in decimals and show me the answer. Okay?
1.6449
This is enough. Okay? So what do you notice about these two numbers? There's a difference between them. This difference value is the error value. Okay? As simple as that. Now, how can I, for example, as a good engineer, approach this number, okay, with just sums, just summing, by summing? Because you know computers, how they work. They can accept operations like addition, subtraction, these kind of things, but they don't know how to do this like from scratch and reach this number, right? Yeah. Okay. So this is what happens. Now the computer can calculate 100 terms, for example, in 1 second, right? So So, for example, 100 terms is good enough, maybe, right? Maybe if I calculated 100 terms, I will reach a number close to this. Okay, which would be good enough, a good enough approximation. This is what we're saying. So the objective is here. The objective here is what? The goal is what? How many terms n we need to do? We need to sum to reach a certain error value. A certain error value. Okay? Okay? So if I want the error to be 0.001, then what should I use? 1.64 and then something. I don't know. If I want the error to be what? 0.001 means that when I have the one here, the decimal at this position is the one different. Okay? And everything else should be the same, which means 0.0. Okay? Is that clear? This is what we need. Okay? So you'll be given an error value. You will be given in a question an error value and the series, and then he will ask you what? How many terms n should I sum to reach this error value? Okay? I hope this is clear. It's a long proof actually. The proof. What do you mean always the same?
Always right 2/6. That's what you mean.
For this specific series. You know, okay. If I ask you this in the exam, what should you answer as a calculus 2 student? You just say P equal to converges. We don't know converges to what, right? But someone actually did this. Someone crazy actually did this calculation and reached this number. It's a beautiful proof actually. But you don't need to know it. Okay, this is what I'm saying. Right?
No, it's not.
Only 2 decimal places.
Equation.
Yeah, for it will be 5, 6, 7, 8. It doesn't matter that much. It's different. It's just different. It doesn't have to be one exactly.
What should the number be?
1.64 and anything here. I don't care. Okay? 5, 2. It doesn't matter that much. Yeah, I'm just gonna put the formula. I'll put the formula. Yeah. So how many terms? I'm gonna put the formula now. Okay. So the formula tells you that the sum or the error of the sum is less than or equal the integration from n to infinity of f of x dx, and that should be less than or equal what? Here it will be the given error value. It will be given. Okay? Good? Rn means it's like the difference between the partial sum, okay, and the actual sum. Right? Now, so let's take an example. Let's take an example. How many terms of are required to ensure that the sum is accurate within 0.0. Okay? So just gonna straight away apply the formula. No tricks here. You just have to do the integration. Okay? But you're gonna keep this as n because this is what you're gonna find. Okay? Stays as n. Don't put it 1 from your head or something, please, huh? So we're gonna say the error value is less than or equal integration into infinity. What's the function? 1 over x ln x all power 4 dx, which should be less than or equal what? The given number, 0.0. Integrate now. Yalla, how do I integrate? What's the technique? Use of station, right? Ln x, right? And then du is 1 over x dx. Okay? And then what do? I integrate Rn is equal integration. 1 over x dx is du. And then 1 over u power 4, right? Do you want to change the bounds or it's ugly? The bounds will be what? If x is equal to n, it will be ln n here. And if x equal infinity, it will be infinity. Okay? Plus less than or equal 0.0. How do I integrate this? طب easy, طب قول لي طيب. يلا tell me.
Use the negative 4 then add 1.
Then add 1.
Yeah, and do the
If I saw someone doing len u power 4, for some reason, I don't know why, when I graded the quizzes, I've seen people doing len u power 4. Don't, please. Okay? So what does this become? U power negative 4 du len n to infinity less than or equal 0.01. Now integrate, what do you get? Negative 3 over negative 3. Okay? So integrate it. And then from ln n to t, and limit t goes to infinity. And this becomes what? T goes to infinity. T power u power minus 3, you can write it as 1 over u cubed. Okay, like this. Let me do it slowly. And then what happens? Plug the t and then plug the limit. Okay, 1 over minus 3 t cubed plus 1 over 3 ln n cubed here. And all of this number has to be what? Less than 0.01, right? Okay. Plug the infinity. What do you get? 0. Be careful here. Here you need to be a little good with algebra. Okay? So I have 1 over 3 ln cube of n less than or equal 0.01. And our aim is to solve for n. Flip first. Okay? Flip the inequality. So what do you get? 3 ln cubed n larger than or equal, because when you flip the inequality, you flip the sign. Flip 0.01. What do you get? What? 0.01. Flip it. 1 over that number. 1 over 0.01 is how much? Someone do it in the calculator. You
1 over 0.
100. Wait, والله؟ والله صح 100 صح. طيب. Divide by 3, what do you get? Ln cube n larger than or equal 100 over 3. First, I need to get rid of the cube, right? So what do I do? I do a cube root. And then, how do I get rid of ln? E. Done. So n has to be larger than or equal e power cubic root of 100 over 3. Can someone tell me how much is this number? Exactly. Yalla guys, we don't have time. It will be 24.99, right?
24.985.
Okay. Now, n is what? An integer, right? You cannot answer 24.99. What do you say? It's larger than 24.9. What's the next integer? 25. If it was 25.01, what's the next integer? 26, and so on. It depends on you. Okay.
Will you use calculator?
Who?
Calculator, instead of all this.
Can you use calculator?
Yeah, but
Like a
equal.
shift solve thing?
Yeah.
You can, but you need to be careful of the signs and
Split and
equality.
equal and then I put it down.
Okay, but be careful of the sign because see, it flipped. It flipped. The sign of the equality flipped. So if you mentally kept this like here, you're gonna pick 24, and that's wrong, right? Just be careful from that. I'm not saying you can't do it. Okay. Any questions? Let me give you the quiz papers.